Is there a quiz? No? Oh.
I mean, yeah, but not for a while.
On Monday?
No.
Oh.
We've only done one section. Okay. On the bottom of this page is where we kind of left off yesterday. So there's something called the vertical line test. And this is a really easy way to decide if a function's graph is a function or not. The vertical line test says that if you can draw a vertical line through the graph and it only hits the graph at one point, then it's a function. If that line hits a graph more than one time, it's not a function. So if you look at this first one, how many times does this blue line hit this graph? Twice. It hits it once here and once here. So because it hits it twice, it's not a function. What about the second one? How many times does that blue line hit it? Just once. So this one would be a function. So if you have the picture of the equation that you're maybe thinking about trying to decide if it's a function or not, if you know what the graph looks like, that's a really quick, fast way to figure out if it is or isn't. Okay, now on to the next page here. We're going to use a graph and not necessarily worry about if it's a function or not, but more so be able to read the graph and answer questions that they're asking about it. And they are still going to have that function notation. So we're just trying to use that to figure out, are we looking at the x-axis or the y-axis here? So this first one wants us to figure out what f of 5 would be. Now 5, when it's placed into the parentheses like that, is representing your x. So this is representing the x coordinate right now. So on your graph, you need to use the x-axis at 5 to figure out where it hits. So the 5 is right here. Where does it hit on that line up here?
400.
400.
400.
400, now it says average T cell count per millimeter. So this would be 400 like milliliters of blood. What's different about the second half of the problem though? So what value of x? They're giving you the y this time. They're saying that f of x equals 100, so the 100 is your y value. Now think about your graph. 100 would be right here. So about where do you think it crosses? 9. And my line kind of goes up a little bit. I think if I had it be more straight, you would see it would go straight through 9. So we would say this would be 9. And what would my label for that? Years. So look for that notation. Are they putting it into the parentheses? Is it outside of the function notation? That way you know, am I looking at my x or my y? Okay. We talked a little bit about domain and range yesterday, which is like the values that are your x's and your y's. But we were only looking at like specific coordinates. So they would give you like a sample set of points that came from the function. Sometimes they might just give you the graph, and you still need to be able to do the same thing, like pull your domain, pull your range. So when you look at a picture like this one, we're going to write this out in interval notation, which is what we were ending chapter 1 with when we had to write it with parentheses or a bracket. That's what we're doing here, and we're trying to figure out what values of x are being used and what values of y are being used. So if I start with my x's, I always just kind of think about how far to the left on the x-axis does it go and how far to the right. And if you need to, you could almost even just like draw lines. Like it goes about there to there. That's on my x-axis. The other thing I'm noticing is that the graph has closed circles at those points, which would mean when I write this out in interval notation, it should have brackets because it's including those points. Now, what's the farthest number to the left I hit? -2, so I need a bracket, -2. And then what's the number onto the right side? 1, right? And it's still going to be bracket. Now that's your domain. We also need to do the range. So I'm going to erase these 2 red lines because my range would be focusing on my y values. So my y's is like how much up and down does it go? Now if you wanted to draw lines like that, they would just be horizontal like this. And again, still we have closed circles on here. So what's the lowest it goes on the y-axis?
0.
0. So bracket 0. And then what's the highest it goes? 3. And again, bracket, because we had closed circles on our graph. So if those lines kind of help you, especially when you have specific like start and end points, sometimes you'll have a graph like on this one. I'll just show if this didn't have a closed circle, let's say that this line kept going down and they drew an arrow like that. Well, that would mean it would go forever and ever and ever in that direction. So you'd have to represent that with a negative infinity because it would just continue to go down. But if they have like specific start and stops, using some of those lines can kind of help you figure out x's versus y's. Because sometimes I'll see students get these switched. Like they'll write 0, 3 for their x's and they'll write negative 2, 1 for their y's because they read the graph wrong. So we've got one more like this. Watch for your open and closed circles here. Let's start with domain, your x values. So how far to the left and how far to the right are my numbers going? Negative 2 to 1. Do I have parentheses, brackets? Good. How about my y's? So how should I write that as like, which one goes first? Bracket negative 1, comma, 2, and then what? Parenthesis. It shouldn't be very hard. Okay, last thing, and this should just be a review, because you had to do this in the last chapter as well. X-intercepts and y-intercepts. What are your x-intercepts? Negative 3, 0. And how about y-intercepts?
0, -6.
Questions on that?
No.
See?
Oh.
I told you guys I went, look, even less than 10 minutes. Look at
Why
that.
don't we just